Welcome to the world of fish culture. From hatchery to harvest, watch how science and nature come together to produce premium quality fish. During this culture, various things to be managed timely, from predators to deadly parasites and poor water quality, every threat can cause huge losses. Your fish may seem healthy today, but hidden enemies could already be attacking them. That's all it takes to turn a healthy fish pond into a disaster. Let's uncover the biggest enemies of fish farming and learn how to stop them to protect your stock before it's too late. To get maximum information, watch this video till end without skipping any part. Let's see how predators can affect fish stock. Here are some ways like predators can consume the fish in the pond. Consume the fish's feed. May transmit parasites and other infections to fish. Scare the fish when they are chasing them up. Cause physical injury to several fish in the process of hunting. May translocate fish to a different pond. In pond fish culture, the common enemies of fish belong to diverse group of the animal kingdom, aquatic insects, including water boatman, water scorpion, backswimmers, diving beetles, giant water bug and nymphs of dragon and damselflies. Weed fishes which compete for food, space and sometimes feed on tender carp fry. Predatory fishes such as murrels, catfishes, freshwater eels etc. which prey upon fry and fingerlings directly. Amphibians, such as frogs and their tadpole larvae. Reptiles, like water snakes, snapping turtles and crocodiles etc. Birds such as kingfishers, herons, pelicans, cormorants, storks, fish eagles etc. Mammals e.g. otters. Aquatic insects 4% of total number of insects fauna of the world. Prey on egg, fry and juvenile fish. All these enemies compete for the food with fish. First of all, come to discuss aquatic insects. Aquatic insects belongs to orders Coleoptera, Hemiptera and Odonaton. Coleopteran species that are harmful for fish belong to following genus. The diving beetles belong to Cibister, Hydaticus, Sandrocotis, Rhehantaticus, Aerides, Lacophyllus, Hypophorus. While scavenging beetles belong to genus Hydrophilus, Sternolophus and Regimbatia. While whirling beetles belong to Dinutes. Hemipteran species that are harmful for fish belong to following genus. Limnometra, the water strider, Notonecta and Anisops, the back swimmers, Lacotrephes, Ranthra, the water scorpions, Diplonicus, Lithocercus, the giant water bugs. Species belonging to all these genera may be regarded as dangerous to fish fry and fingerlings. Notonectides have been reported to be capable of devouring even 10 to 13 mm long fry. Water bugs are highly predacious. They secrete a toxic salivary substance which kills the prey in very short time. Water scorpions attack advanced carp fry and feed on them. Nymph of dragonfly belong to Anax and Macromia, while nymphs of damselfly belongs to genus Inalagmabrium and Ischnura. This picture shows various aquatic insects which are frequently found in aquatic habitats and attack juvenile fish. There are different methods to control predatory insects like manual method, biological method or chemical method. Sometimes individual methods are used while sometimes all these methods are used collectively. Through manual control, removal of predatory insects done by slow repeated dragging, through fine meshed insect net, a day or two before stocking. By using following insecticides: Diptrex 0.5 ppm, Endrin 0.001 ppm, Dieldrin 0.5 ppm, Quicklime 224 ppm, benzene hexachloride 0.1 ppm. Next are predatory weed fishes. Let's see to which genera these weed fishes belong. They belong to Channa, Mistis, Ompox, Wallago, Nandus, Notopterus and Clarias. Predatory fish are hypercarnivorous fish that actively prey upon other fish or aquatic animals, with examples including shark, billfish, barracuda, pike muskelinge, walleye, perch and salmon. They attack fry, fingerlings and adults fish and prey on them. Equally undesirable are weed fishes which, though not predatory on young fish, may compete for food and space. The common weed fish species are Puntius ticto, Rasbora daniconius, Puntius sarna, Ambasis spp, Barilius sp, Colissa spp etc. They generally consume large quantities of zooplankton, the main food of carp and fry, thus directly compete for food. Weed fishes have a high fecundity and breed in confined water. Predatory fish species are found all over the world and they have adapted to various environments and niches. Predatory fish belong to a wide range of different families and the anatomy differs greatly between the species. All predatory fish species have adapted different adaptations for predation purpose. Some predatory fish species have sharp teeth suitable for cutting loose pieces flesh and tearing them from the prey. Garfish species have needle-like teeth that are highly suitable for holding a prey. Catfish have comparatively small teeth, since they do not use their teeth to tear flesh or catch and hold a prey. Instead, they vigorously suck the prey into the mouth. Predatory fish can use a wide range of senses in order to locate a suitable prey. Some predatory fish species carefully scrutinize the prey before they decided to eat it. Some species will rapidly gulp down their prey and regurgitate it later if they find it unsuitable. Vibrations in the water are very important for many predatory fish species and their hunting instincts are triggered by movements. Scents can also play a vital role, and the scent from dead food is more likely to attract scavenging fish species than predators. Prior to stocking, drain or net ponds to remove fish-eating species such as the northern pike. Northern pike are opportunistic feeders and will generally attack anything they can swallow whole, which can be as much as 50% of their body weight. Barrier screening on both the inlet and outlet of the pond is usually effective for keeping out larger fish. Let's see how predatory and weed fishes can be controlled. Weed fishes are harmful to culture of carp fry. They compete for food and space. They directly prey on them. It is very important to remove all undesirable fish from nursery pond. It can be done by the application of quicklime and then drying up it for a fortnight. Netting operations are also effective to control these fishes. Toxic chemicals can also be used to control certain predatory fishes. However, some fish species poses habit of staying at the bottom or bury in the mud for considerable period during netting. So, it becomes necessary to treat water with some toxicants. Chlorinated hydrocarbons like aldrin can be applied to the fish pond at a rate of 0.2 ppm. Dieldrin at a rate of 0.01 ppm and endrin can be applied at a rate of 0.01 ppm. Application should be completed 1 month before stocking the fish in the pond. Let's discuss harmful amphibians. Amphibians, including larvae and adults, act as competitors of fish for food. Control measures include destruction of frog spawn, application of ammonia and trapping of adult frogs in baited traps. Let's discuss harmful reptiles. These includes water snake, snapping turtles and crocodiles. Let's discuss harmful birds. There are a number of fish-eating bird species which do serious damage in fish farms. Kingfishers, herons, fish eagles, pelicans, egrets etc. are considered to be the worst of enemies of fish. The two species of kingfishers widely distributed in our region are Halcyon simrensis, white-breasted kingfisher, and Cerral rudis, pied kingfisher, of fish. Their control method includes covering the ponds with nets or wire mesh, control of birds by using scaring practices and use of shoot or trap if legally permitted. These are some bird species which do harm to juvenile fish. The only assurance of eliminating bird predation at aquaculture facilities is total exclusion of birds from fish holding facilities. However, total exclusion may be impractical for many facilities due to size of operation, expense, or interference with management activities like use of barriers and frightening techniques. Satisfactory results may be obtained with the use of partial exclusion and non-exclusion barriers if combined with other control methods. Which control method to be used depends on a number of factors, including the number and species of birds involved, the severity of the predation problem, and the type and size of facility to be protected. Complete enclosures that prevent predators from gaining access. Partially covered systems that interfere with the feeding behavior of predators. Another successful technique may be the use of complete enclosures. Complete enclosure, caging, of ponds and or raceways with screens or nets. All exclusion structures should be long-lasting and strong enough to withstand the weight of several large birds. They should keep the barrier from sagging to within the bird's striking distance to the water. The barrier should be visible to birds to minimize accidental injury or entrapment. Exclusion structures should allow for facility maintenance, feeding, harvesting and other operations. Total exclusion is the only method that can provide long-term control against all bird predators. Partially covered systems include overhead wire, line, net, screens, perimeter fencing and devices that discourage birds from entering the facility. Overhead lines and wires, heavy-gauge monofilament lines, high-tensile galvanized or stainless steel wire suspended in a grid pattern or in one direction over the water surface. Spacing between wires or lines varies with bird species. Overhead line wire systems are most effective against flying predators such as terns, gulls, cormorants and ospreys. Wading birds can access ponds by landing on shore and walking to the water. These areas should also be protected by perimeter fencing. Use of charges must be non-lethal to humans and birds, low voltage. Fences used in combination with overhead lines wires may be successful at deterring both wading, walk with effort through water or another liquid or viscous substance, and flying predators. Frightening techniques are most applicable for short-duration problems, 1 to 3 days, as birds will quickly lose their initial fear. Start the frightening regime before the birds establish regular feeding patterns. Times change the location of frightening devices often, particularly noise-making ones. Times long-term results may be achieved by using a combination of methods and by frequently alternating the devices used. Frightening devices and techniques discourage birds from feeding, roosting or gathering at a location. Frightening techniques rely on sight and or sound stimuli to discourage birds from remaining at a site by making the birds believe the site is dangerous for them. Success in frightening birds away depends on the number of devices used, how and where they are administered, and if their use precedes the establishment of the bird's feeding habits. Noise devices should start and stop at varying intervals and be moved to various locations frequently. Distress calls, recording of species-specific distress calls, should be used as soon as birds arrive. Cracker shells, modified cartridges that contain a firecracker fired from a shotgun, whistle bombs, screamers, screamer rockets, bangers, 15mm cartridges fired into the air from a handheld .22 caliber pistol. Automatic exploders to propane gas or acetylene gas is used to operate a small cannon equipped with an electronic timing mechanism which emits loud explosions at adjustable time intervals. Next technique is use of visual scarecrow device. A variety of visual devices are available for scaring night-feeding birds. As with noise-making devices, the effectiveness of visual scare devices is often short-term, as birds quickly become accustomed to them. Combined use of these devices with other methods provides effective control. Use of light also give required results regards preventing predators. Construction flashers, area lights, revolving beacons and strobe lights. A variety of light-emitting devices can be used to confuse, frighten, temporarily blind and interfere with activities of night-feeding birds. Some mammals also appear much dangerous and cause lots of damage. With the exceptions of Homo sapiens, there's only one serious mammalian predators, the otters with Himalayan otters, L. lutra, and Indian otters, L. perspicillata. Otters are aquatic carnivores with broad depressed head, short webbed legs, body covered with dense oil grayish fur, tail thick and somewhat flatted. Ear pinnae very small, mainly nocturnal in hunting activity and shelter by day in burrows in the banks of rivers or ponds. Food mainly consists of fish. Otters may cause losses up to as much 80% of the fish stock. Kill more and consume less. Otters can be controlled by catching them with special otter traps. Mammal predators chewed or partially eaten fish may be a sign of predatory mammals at an aquaculture facility. Mink are usually the most problematic of animal predators found at stock dugouts in Alberta. The raccoon, skunk and otter can cause problems in some areas but to a much lesser extent. Thanks for watching. Must comment in the comments section if you found this video helpful in your course of study. Like and share this video. Subscribe this channel to get more informative videos and to become part of a growing scientific community.